Okay, so we're moving on now to example 12, where hopefully you'll notice if you look at the problem that it's a little bit different. And it's a little bit different because this time you have a negative exponent on the outside. So you have a quantity being raised to the negative second power. So this is going to take a little bit more thought because as I raise 5 to the negative second power, you have to stop for a minute and think to yourself, okay, 5 to the negative second power is, think back, it's the reciprocal of 5 squared. So if 5 squared is 25, this is 1 over 25, right? So I'm going to set up 1 over 25, and then I'm going to follow the power of a power rule, which says that I'm going to multiply the exponents here. 4 times negative 2 is negative 8. So I have base A to the negative 8th power. Now this has to get simplified, and it's all going to become one fraction. So a to the negative 8th, remember, is 1 over a to the 8th. So what you could do is you could just make this 1 over 25 a little bit, make the fraction line a little bit longer, and bring the a to the 8th down in the denominator as a positive 8th power. Okay, and you can take a shortcut if you like. You can kind of do this part early. So if you see that this up here is going to be a to the negative 8th, you can just put it in the denominator as a to the 8th and do it all in one step. And there's your final answer with no more negative exponents. Okay, same thing on example 13. Pause the video and try that one. So again, I'm going to take a minute and think to myself as I raise negative 4 to the negative 3rd power. This is negative times a negative times a negative, so it's going to remain negative, and it's the reciprocal of 4 times 4 times 4, which is 64, so it's negative 1/64. Okay, so I'm going to start with negative 1 over 64. I'm going to start taking that little shortcut that I told you about. So I have x to the first. I'm multiplying exponents here. 1 times negative 3 is negative 3. So if I have x to the negative 3rd, I'm going to just put it in the denominator as x to the 3rd. Okay, again, because x to the negative 3rd is really 1 over x to the 3rd, and I'm going to multiply it by 1 over 64. So I can just take a shortcut and put it in the denominator with the 64. And then I'm going to do this a similar thing with the y. I'm multiplying 3 times negative 3, so that's y to the negative 9th. Since it's a negative exponent, I put it in the denominator as y to the 9th. So it really is 1 over y to the 9th, but it's all being multiplied together and creating this one fraction. So there's my final answer, negative 1 over 64, x to the 3rd, y to the 9th. Okay, pause the video and try example 14. All right, so I have negative 8 to the negative 2nd power. Remember, negative 8 with the parentheses squared is positive 64. So this is the reciprocal. This is positive 1 over 64. So I start with 1/64. I'm going to multiply exponents. I have m to the negative 3rd to the negative 2nd. So negative 3 times negative 2 is positive 6th power. If I have m to the positive 6th power, right, that is, I'm not taking any reciprocal, so that's going to stay in the numerator. It's going to go right here, multiplied with the 1. So 1m to the 6th, I'm just going to erase the 1, if I can. It's not letting me erase my 1. All right, so I want to do 1m to the 6th. So what I'm going to do is I'm going to go m to the 6th. Okay, because the 1 is now invisible. I have 1 times m to the 6th. And then I do the n. I multiply those exponents. 6 times negative 2 is negative 12. So this is n to the negative 12th. Again, that's 1 over n to the 12th, right? So I'm going to just stick it in the denominator as n to the 12th. And there's my final answer. This little side work, I'm just doing it for the purpose of showing you. You don't need to show me any of that. Okay, so you could literally just go straight to an answer here. And if you could pause the video and try example 15 is going to be our last one. This time you have more steps. You have to raise all this to the negative 2nd power. You're going to get an answer. You have to raise all this to the 2nd power. You're going to get an answer. And then those two answers are going to be multiplied with one another. So give that a try. Okay, so 4 to the negative 2nd. I'm going to do this now with fewer steps on the side. 4 to the negative 2nd is the reciprocal of 4 squared. That's 1 over 16. Okay, I'm going to multiply my powers. 3 times negative 2 on the x is going to give me x to the negative 6th, so I'm going to put it in the denominator as x to the 6th. And then y, 2 times negative 2 is negative 4th power, so that's also going to go in the denominator. So it's going to be y to the 4th in the denominator. Let me move this over. Okay, so I have y to the 4th in the denominator. And then I'm just going to slide this 1 over so it's more in the middle. Okay, so there's my first answer. And then z, I'm going to multiply 2 times negative 1. I have z to the negative 2nd, so I'm going to take a little shortcut again. I'm going to go like this. So remember, it's z to the negative 2nd, which is 1 over z to the 2nd. I could put the 1 if I want. But on the next part, the 1 is going to become invisible. So because now I have x to the 4th squared. So 4 times 2 is 8. So I have x to the 8th. Since that has a positive exponent, it's going to go in the numerator. So instead of writing 1x to the 8th, I'm just going to erase the 1, and I'm going to write x to the 8th. Okay? And now I am going to simplify, and we're going to encounter something new here, which we're going to do more of tomorrow. But so 1 times x to the 8th is x to the 8th. I'm multiplying numerator times numerator. Now denominator times denominator, I have 16 x to the 6th, y to the 4th, and then times z squared. I just put them next to each other because I don't have any common bases. Now, this is the new part that you're going to encounter at times, depending on what, so there's lots of different ways of doing these, and if you find yourself more comfortable doing it a different way, and you're still arriving at the correct answer, that's okay. You can do this any way that you like, okay? There are multiple variations of like different orders and different steps that you can take. So here, I come across a situation where I have x to the 8th in the numerator and x to the 6th in the denominator. Another rule that we're going to talk more about tomorrow is you can never leave the same base in the numerator and denominator of a fraction. This needs to be simplified. And we simplify doing the opposite of what we do for multiplication. So if in multiplication we add exponents, this is division, we're going to subtract the exponents. So 8 minus 6, I'm going to subtract those, and I get x squared. And if you learned either last year or the year before that there are basically in the numerator you have x times x times x times x. You have 8 of them multiplying. So 1, 2, 3, 4, 5, 6, 7, 8. X is multiplying in the numerator, and then you have 6 in the denominator. 1, 2, 3, 4, 5, 6. And each x divided by x cancels to 1. Right? So you're left with whichever one has the higher exponent, that's where your x remains, where you have more left over. That's where your answer will go. So I'm going to subtract, and I'm going to have x squared in the numerator, and in my denominator I have 16 y to the 4th z squared, and that's my final answer. Okay, so if you encounter a situation where you have the same base in the numerator and denominator of a fraction, just subtract those exponents to simplify. All right, so we're going to stop there. You guys have some homework that's posted, and please use your notes to help you. All right, thank you.